Are we live? We seem to be live. Um, my stream is warning me that my sound might be slightly too loud, but because I always hear people say that it's not loud enough, let me know if it is too loud, if it's distorting, or if it's good. Please, if you're in chat, let me know if the sound's good. Hello, everybody. Welcome. It's been a while. Yeah, it's totally going overpowered now, so I'm gonna go a little bit down. Let's see if that's good enough. Hope so. Good. Yeah, it's been a while. Welcome. We're gonna do something slightly different tonight, just to do something different. I've just been working on something in my spare time, something that I wanted to play around with and see if it's any good, if I can make it work the way that I want it to work. And yeah, I've only got the basics done, so the really interesting bit I'm hopefully going to get through tonight. I have no idea what I'm doing, so stumble along with me tonight, I would say, and we'll see if we can get it to work or not. Matt, what are you doing? Why are you playing around with my things? No, I do not want you pulling things off my table. That would be very bad. Oh, no. Sorry, my cat's suddenly being annoying. She's cute. Okay, so the idea that we have. What are you doing, cat? What is over there? What are you playing with? What are you trying to find? That was just a cable. Do not play with my cables. So don't know why that was on the floor. Probably because you were playing with it. You probably want to play with that. Sorry for the interruption. Cats always get in the way. She was sleeping nicely and she hears me talk and immediately she goes like, I can get attention there. Okie do. We'll see if she jumps up on my table during the stream tonight. That's going to be fun. I'm not so happy that you're making so much noise, cat. Let's get that. That's why you're. Yeah, there we go. So we've got a character here. That's me. Well, sort of. And as it says on the shoulder. Thanks, Simgon. Glad that it's not too loud. It says on the shoulder here. This is from Ready Player Me. So let me just quickly find that. For those who are not aware of this beautiful little site, that is this little one, Ready Player Me. And this is a little site that you can create an avatar for yourself, and then you can download the avatar as a GLB file, and then you can use it, which is kind of cool. And that's what I'm using over here. And if I recall correctly, what you can basically do is you take a photo of yourself, and it sort of tries to mimic yourself. It's been a long time since I set this up. Been using it as a stand-in model here and there. Yeah, it's close enough to me, and it's good enough for our little test over here. So right now I was just working on making this guy walk in an animation, or that's the goal actually, to make it walk. It doesn't walk yet. I need to get the right animation here. So it's just bobbing around, but all that's in the animation is actually going from moving this guy along the path. The rest is all done procedurally. Now, I think for starters right now, because it's fun going after or through a little thing like that, but I actually want to create a very quick character controller for this. What are you doing, cat? Crazy cat. Hey. I actually want to create a very quick little character controller for it, so that we can actually move it around. Yeah, it looks funny right now. It's far from where it needs to be, but we'll get to what it does so far once I've got the little character controller going, so that we can actually move it around and see what it actually does. I'm gonna move the view back to one viewport so that we just have the character here. And I'm just going to create a new scene for this. Why does it? Here we go. Just going to call that test 2. And I'm going to put my room back in there. There we go. It's just a little room model that I made for testing. Hold on. Why don't I grab this pussycat and I throw that over there? Hopefully you're going to play over there. She found a toy. So here's our little room. Now just to check. Yeah, I just had to pass stuff here, so that's not what we're going to do this time. We're just going to start with test 2 here. Go ahead, change it around. I want a little character body. And then we're actually going to put our avatar as a child of the character body here. Boom. Yay. All right. And you can actually already see that as I was moving this around, it's actually doing something. Or trying to do something. Not very good. But hey, we only got the basics right now. So, really, Cat? Bloody hell. Why does she suddenly want to play? She's been quiet all day. Okay, cool. So we're just going to create a really simple character body script for this. Actually, I'm just going to create that on the roots. It's fine. Oh, why does it not do my default character body logic? No, we can... No, I want a default character body logic. Why did we not get that? Close and clear. There. And let's get rid of that guy. Delete. Remove. There we go. And now let's go add that back in. There we go. That's what I wanted. Okay, there we go. So this creates a default character body bit of logic, and all that this does is move the character with our, I think it's our arrow keys, around. Now the other thing that I want to do is I want a camera, but excuse me. Yeah, I just want to go, for now we'll just put a camera there. So we're going back to that double view port. There we go. Oh, I thought I put the camera as a child. I actually did not. Here you go on the camera. This snap thing doesn't always work the way that it should. It sometimes goes the wrong way around. Thing is, oh, the goal is to create logic for the avatar. So this is an avatar scene that has some inverse kinematics set up for both the hands and the feet. But the logic that I want to build is that when the character moves around, it actually starts walking, but not with an animation, but by doing it with programming logic, by simply moving our targets to where the feet should be and just getting a walk cycle that way. But I was doing that with just an animation around a path, but I actually really want to control the character walking around and seeing what it does. So we need to set up a really quick character controller so that our character can walk around. But I actually want to... I want to make a separate, and I just want to get this to follow. Hey, Rodzilla, how are you going? Hope you are good. Back to that. Okay. And now what I want to do is actually a remote transform and camera roots. No, I don't want that. No, I do. I'm going to assign that to the camera root, but the thing that we're going to do differently is that we're not going to do rotational scale. So we're just going to position this in the same place that our character body is, but even if our character body turns, we want the camera looking from the same angle. And that now means that we can go and move this guy a little bit more. Why is it suddenly like that again? Bum, 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 bum. There we go. So hopefully that will allow us to follow. So let's go and see if that runs. Oh, we don't have a collision yet. So we're falling through the ground. Static body. Da, 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 da. Okay, and we want to have a collision shape on that. So this is going to become the floor. And this can simply be a world boundary. All right, cool. So with that, oh, cancel. I just want to do that one. Why does it? Okay, still. Oh, and we need a collision shape for our character. Yeah, that was a bit dumb. It's going to be capsule shape. Capsule shape. I think I'm about 185. That can be a little bit smaller. And that needs to now go up. Let's go and make that a favorite property. And we'll put that on 1.9. So that should nicely be there. Cool. Okay. It's supposed to save that location. Why isn't it? Oh. All right, so we're moving in the right. So you can see that, I've got a little bit of it working yet, but not all of it. Actually, the way to solve that is just to move our character 180 degrees. So what we're simply going to do, and again, I also want to favorite that one. Don't know if you guys know this new ability yet for favoriting properties. It means that they're always at the top. Makes it a lot easier. There we go. And with that, I actually want to have this one the other way around. So now we're facing the way that we're expecting to. And then, ooh, cool. All right, you're busy with game jams. That's pretty cool. I wish I had more time to do game jams. Okay, so now, damn, why does it keep opening up in the wrong spots? Probably need to put that into a ready function to make sure that that opens in the right spot all the time. Yeah, so now forward, backwards, left, right. So ignore the animation right now. That's not finished yet. We're just doing some basic stuff. But yeah, that's cool. All right. So let's go and have a look at our standard character body script. Now, one thing that I personally don't like is that this is done in local space. This is a transfer for the character body, which is fine because the character body is on our root and our root doesn't have a transform. But let's say that, I just wanted to show everybody this. Let's say that, we're on a moving platform or we're on a platform or something, and that's like rotated. Watch what happens now. I keep wanting to do that. So now you can see that I'm actually, oops. I'm moving diagonally. I'm not moving forward and backwards. And it's a simple fix because velocity is working in global space, but we're using our local transform. So if we change that to global transform, all of a sudden our script works. And I don't know why that is actually done so in the standard script, because in my opinion, that's a bug. So now, even though our room is rotated, we are moving the right direction. So if that's ever a problem that you run into, nice little thing to know is that it's a pretty cool little script, but that little bit is wrong about it. Hey, Buka, how are you going? All right. So yes, Material Maker. Rodzilla is the developer of Material Maker. Very cool little program, which I do not use enough. I actually need to start doing more of that. Okay, so here's another thing that I find interesting about the script is that we have a nice slowdown when we stop moving. So we don't stop on a dime. We move slowly to stop, but we don't do the same with the speed up. So I kind of like, well, first of all, I like to make these export variables. And again, I'm doing a bit overkill because we just need the script just for handiness. But Hey, Nederlanders, yay! Um, so yeah, so let's go and actually call that movement. Speed float is 5, and I'm going to make another export variable, and I'm going to do that transition speed, I guess. Okay. So what I actually want to do is I don't want to do this if direction check. Instead, we are going to do that times speed. So we actually want to, and of course, if there is no direction, then that's 0. So we're going to go lerp from the move forward. Is that a lerp? Moves from toward 2 by the delta amount. Will not go past 2. Okay. So what I actually want to do here is times delta. There we go. So now we no longer need this. And then obviously I want to make use of that one. So now we're always lerping towards the speed. I'm not quite sure why do we have a move toward function if we already have a lerp function. I don't know where that came from. It's not in here, so excuse me, my nose is being annoying. So with that change, and the transition speed is likely too low, but yeah, so we're speeding up slow and then slowing down. Well, we're having a problem with the way that my acceleration thing works the wrong way, which is really weird. Okay, so that's definitely something that I need to tweak, but we'll talk about what I've built today in a minute. I just wanted to get the movement logic working first. So let's for fun just put that back to 5 because that's basically what it was before. No, I think I want that to be way more. Let's make it 15. Because again, I'm multiplying now by delta, so okay, that's better. So now we can see that we have a little bit of acceleration in there and a little bit of deceleration in there. Cool. All right. While we're on here, let's also go and make a jump velocity settable. Jump velocity. There we go. So we no longer need you. So we can, oh, I think the jump velocity needs to be a little bit lower. I don't really care about jumping right now, although we probably need to do something with our animation eventually when we go jumping. But let's tone that down a little bit. Let's not make it jump so crazily. Okay. Oh, that's a little bit too little. Actually, before we do that, get gravity. Oh, that's a new function. Oh, that's really cool. I like that. I didn't know that that was actually in there, and we're already using that. That is way cool that we have that. Okay, let's go like that. And again, I don't really care about jumping right now. I'm probably not going to get to actually doing a jump animation today, but okay, that's the movement there. Now we need to be able to rotate. So, am I going to do that on mouse? I think I'm going to go and do that on mouse. So we need to have some logic for mouse capture. All right, let's see if I remember that from the top of my head. So we want to check on unhandled input. If event is input event mouse button. So if we are clicking on this, we want to capture the mouse. How was that again? Ooh, that's a good one. All right, mouse mode. I think that's the one that I'm looking for. Yes, it is. On what is this? This is on. Oh, it's just directly an input. Okay. So this is going to be input.mouse. Oops. mouse mode is captured. So if we click on our window, we capture our mouse. And that also means that we need to be able to get out of there. So do we do that? Yeah, we can do that as well. If event is input event key, I think. So we're going to bypass our. Are we going to bypass our actions? Do I want to bypass my action stuff here? Kind of do. No, I kind of don't. So let's actually also let's build our own input map. I never like using the input map from that's by default. So we'll add an action called jump, and that's going to be our space bar. We're going to say move forward. That is going to be up or W. Move backward. That is going to be down, down, or S. Move left. This is going to be left key, and obviously, you know, this is way overkill for what I want to do tonight. But obviously, normally you would also put controller inputs in here. But for now, this is good enough. Right. And D. Okay, and this one actually I'm going to call escape. Probably should have a different name, but I'm just going to call it escape for now. Or shall we call it another name? Exit mouse. Why not? All right. All right. So, and actually, then I do not want to do that. This is just going to be called jump. That's going to be move left, move right, move forward, and move right. Let's see if that still works. Forward, backwards, left, right, and jump. Okay, cool. Happy, happy, joy, joy. So now for a mouse capture to finish that. Oh, lucky that I didn't click on the mouse, because I would. Well, I could probably have done Alt F4, but so we're just gonna check that here. If input action is action just pressed, and we want our exits there. Input.mouse mode is input. What's the default value for this? I think it's mouse visible. Let's double check that. Doesn't say. Well, I'm guessing visible being 0 is the top one. You should be able to see. It's not showing the default here. I thought it showed a default there. I guess it doesn't. Well, I'm going to assume that without it showing a default, that the default is 0. Yeah, basically that's what we're going to do in SimCon. So I first want to, just get a controller that we can move around so that we can test. So all that we need to do now is actually move left and right. So this we do on an unhandled input because we only want to react on a click if nothing else reacts on it. So if we have a 2D UI object on our screen and we click on that, then that is going to handle the event, and we will not get into unhandled input. But for our mouse inputs, we're going to check our normal inputs. So here, we're first going to say if inputs.mouse mode And now we're going to check if it's not captured, then we're going to return. So we're only going to react on mouse events if we actually have captured the mouse. And we're simply going to say if event is an input event mouse motion. So that is when we move our mouse. And we're only going to react on our mouse moving from left to right because we're not doing a first-person controller. We're doing a third-person controller thingy. We're just going to rotate around the z-axis. So what we're going to be doing here, and now I need to think, do I want to keep a variable for that? Yeah, I think I'm going to do that just to work around any imprecisions is rotated on y 0.0. Boom. So this is going to be actually oops, don't do that. There we go. Plus event dot relative dot x, and obviously we want to have a export var rotation speed. Just going to keep that to 1. I'm not sure what a good speed is, but we're going to do that purely based on our mouse's DPI. And now I'm going to clamp that to what would be smart here. Is it minus pi to pi? Or are we going to, yeah, I think it's minus pi to pi to make sure that we're rotated around a single one. It'll be independent. Yeah, no, Zimcom, this is nothing to do with XR. This is something that you could use outside of XR as well. I do want to use this eventually for XR, but it's not specific to it. So, yeah. Okay, and actually seeing that we're doing it like this now, and the reason why I'm using a variable here is just to work around any, whenever you rotate an object and you keep rotating the transform, you get small little inconsistencies, and eventually that breaks down. If I directly manipulate our transform dot basis dot, I thought there was a, hold on, no, it's directly on here, right? Yeah, rotation, that's what I was thinking about. So if I would directly change rotation.y, this variable actually doesn't exist. When you read it, you're going back from your transform, it's calculating the angle and returning the angle. So it's fairly computational to get to that variable. So it's actually better to just have something like that and then just assign it. Just it's nitpicking. It's not really important, but there is a small performance improvement doing something like that. So with that, my mouse does nothing until I click, and ooh, that's way too shaky. So, all right, that is because, of course, I probably want to do a, you know what? I'm going to do degrees to, oops, right here. It's not really that I'm rotating in degrees, but this is probably nice enough to not have to do some really low value of that, but just make it something that's a little bit, there we go. We're rotating the wrong way, and it's not wrapping around. That's, of course, something that so that's the thing that I did wrong here. I shouldn't be doing clamp. I actually need to do fmods. And instead of that, we're doing 2 times pi. That's probably good. And we were rotating the wrong way. So let's go and, I actually think it's nicer to do it like this. Okay, click on it and we can rotate and rotate back and rotate and rotate back. Okay, now the other thing that I noticed is because I've got my rotation like this, we obviously want to initialize this properly. So let's make that an onReady var, and we're going to do that rotation. Rotation.y. And maybe, you know, if we ever have external okay, I probably want to make it a little bit less aggressive in rotating. So I might still want to bring that down a bit. Let's do something like this. Okay, yep, that's better. Okay, so. Well, yeah, there's no collision objects on anything here, so I can probably just walk outside. Like, hey, I'm outside. But hey, we'll make that later. Now, I do think yeah, that's probably with the rotation. Anyway, it doesn't really matter. Okay, so one more thing that I want to do. Hey, Cyber Herberino, how you going? What's this? So you want to see how Euphoria physics works dynamic, physics animation for characters. Is there anything similar? Free and open in Godot or open source? We don't have Tau? I don't know. I'm just so used to doing 2 times pi. I wouldn't be surprised if we have Tau. Yeah, we have got Tau as well. Why not? And DK, yes, Jolt is now fully in the engine. So if you go to Physics 3D, you can see that Physics Engine by default is our default, which is right now Godot Physics. But you know, just for fun, I can turn it on to Jolt. I like Jolt. Jolt's not bad. But for what we're doing tonight, it really doesn't matter which one we're using. It should work just the same right now. So let's actually go and make sure that the size of my project at least is good. Let's see. This should be... What am I running? 1920 by 1080? Maybe. Absolute. Okay, so what are my display settings? What is my resolution? 3440. Okay, so that's going to be 3440 minus 1920. And that's going to be 1440 minus 1080. Okay, let's see if that does what I hope it does. No, the positioning does not work. It does not listen to the absolute position. So the size of my window is correct. Okay, cool. The size of my window is correct, but my positioning is not, which is annoying. So this absolute positioning does not work. Lovely. I guess nobody ever tested it. Anyway, it's the right size now. I'm moving it into position. It's not that hard. One last thing that I want to... No, actually, 2 things I want to do before we really get started in it. First, I want to have a ready function, and in that ready function, we are going to make sure that we default with our mouse mode captured, so that I don't have to keep clicking on the bloody window. Actually, no, I'm not going to do that, because how can I move the window in place if I'm capturing the mouse right away? So I'm not going to do that. But the other thing that I want to do is I actually want to do a speed up. So we're going to go back to our input. Do you have any insights, DK, into what? Into the... Hold on. I don't know much about animation, to be honest. Most on that topic. So what exactly are we looking for? Dynamic physics animation. I'm not quite sure what that refers to, DK. So you're gonna have to let me know a better example so that I know whether that is something we have. I have a feeling there isn't a whole lot around that. Okay, so where were we? Oh yeah, I just wanted to do a speed. Actually, no. I'm just going to call that run. And we're simply going to say that if we press the shift button, we are going to run. Cool. All right. And for that, we are going to then say for speed multiply, actually multiplier equals if input is action pressed shift, there we go, else 1. So we're going to get a little speed boost if we do that. And I actually want to go and our movement is direction times movement speed times speed multiplier. And actually I want to go and I'm going to put that over here. Vector 3. So I want that just to be it's overkill, but just to be nice, I just want it to be 0. I'm going to go and move that over here. And we're going to say that only if we are on floor, we're also always going to do that, because then our, so here is what actually this is going to become movements, that's just going to go and be that. There we go. But I think I want to go and do this slightly differently too. I'm going to move that over here. So if we're on floor, we can jump, but if we initialize our jump, we are not going to do our direction logic, and therefore we will slowly slow down. That needs to also go one back. Okay. And potentially, because this is now going to make sure that if we jump, we're going to immediately slow down, but we might want to slow down less quickly. I'm not going to worry about that too much right now. All right. So now, in theory, if I've done all that right, I should be... I haven't got a main scene set up, and I don't actually want to set up a main scene. There we go. So now we're moving. Okay. No speed boost. Actually, I want to make my movement, my default movement, a lot slower, so that we actually can see what's going on. But I don't get a speed boost. Okay. No, I don't want sticky keys. Go away. I'm pressing shift for a different reason. Alright. Pressed shift. Oh, that wasn't shift, that was run. There we go. Dynamic ragdoll, like we see in GTA 4. DK, if you look at some of my earlier streams, like probably 2 or 3 streams ago, you'll see that I'm setting up a whole ragdoll on stream for my my hand physics interaction, and you can grab the ragdoll and shake it around and do funny things with it. So and it's actually quite easy to set up a ragdoll in Godot. It's a lot of fun. All right, so okay, I think the run needs to be a bit more pronounced. I'm actually thinking we have a movement speed. Let's make this a run speed. Let's make that to 5. And we're just doing... No, at this point in time, this can be movement speed. No, sorry. This needs to be movement speed. This needs to be run speed. Now I'm actually kind of happy that we can just put that over here. We do need to do that between brackets, or else it will do it in the wrong order. There we go. So now we have, if run pressed, we have our run speed, also movement speed, and we still have our ramp up for our speed there. So We are walking, we are moving faster. We are walking, we are moving faster. All right, so time to start looking at what craziness I've built to make my character do this dumb walking animation. Well, the start of a walking animation is doing far from what it should be doing. So let's have a look at this avatar that I made. So important to know, our character body together with our collision shape, that is just our character system. Camera. Let's go back update. Camera. Control. So that's just our normal character body. So obviously we could have any shape there. It doesn't matter. It just moves around. It's a character body. That's it. Nothing special there. But we have an avatar node there, which is the avatar node that I've set up. So our avatar node here is just a GLB that I have imported. I've got editable children on, but that's just so that I can add things into there. I've not changed any of these things. This is the GLB exactly like I got it from Ready Player One. I have put it on a pivot so that my avatar can actually be on the ground. Makes it easier to add it to our character body that is also designed to be on the ground. Plus that way I know what the ground level is. Then the pivot is on chest height or just on base of the neck height, kind of. And then our avatar is a child that and move down, which means that, you know, I can, why does that not want to work again? What's wrong with you? Oh, because my logic is on. Let's turn my default logic off so that it doesn't get overridden. And that doesn't do enough. Why does that not enough? You can see that it keeps putting it back to 0. Let's make my life easier. Where's my... Oh, I'm on the wrong one. Oh, because I've got all the other ones as well. I'm just going to make my life easy. Just remove that this is a tool script for now because we're doing everything running now. I made it a tool script so that all the animations work inside of the editor and I can test them out. But now that we have a proper test scene, that's overkill. So that should now mean that I can finally, without problems, move this. No, I still cannot. Do I need to reopen this? I might need to reopen that before that does something. No, it does not. Yeah, that's now because that is on. I was happy to do that. Ah! That was the wrong key. Oh, now it's working. So not quite sure what was going on there. Probably because the snap thing was on. But anyway, that's the whole point, is that we can move this guy forward, we can move this guy backwards, and we can obviously move him up and down to get that, you know, the normal bobbing of the avatar. Yeah, it's me. So, you know, it's me. My name is Bass. So this is my avatar. Ooh, yeah, an Apple engineer contributed to Godot engine for Apple Vision Pro. Yes, he did. Yeah, there's you know, can't talk a whole lot about it, but there's a couple of people at Apple who are currently working on stuff, mainly focused on Apple Vision Pro. So very cool. But I'm very hopeful that it's going to mean more than just Apple Vision Pro, because obviously, in order to make things work properly in Apple Vision Pro, you also need to fix up things on, you know, on the rendering side. So who knows what they are going to do for us? Very exciting. Hello, Rails. How you going? So yeah, I am very excited to see what is happening there. Anyway, now that we can do that, I am going to turn my tools back on, and I am going to reopen my avatar. Because there's more that is in here. So let's go and have a quick look through the code that I've written so far, just to get an idea of what everything does. So you can see that there's a bunch of export variables here for leaning. There's a bunch of export variables for the hips movement, and we have a bunch of IK things, just so that we can control things outside. Cyber, that's in the works as well, but can't say much more than that. But yeah, we want the XR editor to work on more platforms, but there are some things that need to be done before that is possible on all the platforms. So, but it is something that we're working on. Of course, won't happen until it's finished, but yeah. So yeah, we've got all these export properties, most of the settings, and we'll go through the code to see what they do in a minute. But I'm going to start with actually the IK setup, which is very basic, very straightforward, but it's divided into two parts. We have the IKs for hands, and we have the IKs for feet. Here I've got some helpers, which is nothing more than a node that helps me set up where the magnet is, because the way that you set up a magnet, so the magnet is where if you have multiple bones and you're calculating your IK from the start bone, go away with that, from your start bone to your finish bone, then the rotations for the in-between bones can be any which way. And with the magnet, you try to pull a certain joint towards that magnet. But the problem that we have is that's just a vector here. That means nothing to someone setting this up. So I've just created a little helper node, and all that this does is when the editor is running, and I might actually remove that or make that optional because I'm probably going to be moving that around. But in the editor, all that I'm doing is in my process, and I'm continuously updating the magnet position so that I actually can adjust where the magnet is by just moving this around. You can see that if I change that magnet, then the way that my leg bends changes. So yeah, that's what that does. So yeah, like I said, I don't have the magnet set up for the arms. I probably will create magnets for the arms, but for now I haven't got that set up. But I've got IKs for all four, and all that these do is, they're going from a bone to another bone. So if we look at our armature here, and that was going from our left arm, which is that bone. So it starts actually over here, and it then goes to our hand, which is, well, it's that part there. So basically that bone, and the orientation of this is being controlled by the IK. Now I auto enable the IK, so when we look at our default targets, I can move that around, and the IK does something. It's not perfect, but it does something. So and the idea here is that we have default targets for our left hand and right hand, and default targets for our left foot and right foot. With in this case, with left foot and right foot, I've got a helper node to help with orientation. The bones of the feet are kind of weird, and I wanted to have nodes that are normally aligned to manipulate. So we're going to be manipulating those two. And again, same thing happens here is, we can move that around, and here you can see where that goes wrong. So we're going to have to do something more with the magnets. We're not just going to animate our foot position. We're also going to do something with the animation of the magnets. But for now, that is fine. There we go. So that is the default logic that we have. These are simply placeholders, although I do plan to do like arm movement when we're walking, but I'm going to be focusing on the feet for now. However, there's something special about the left and right hand. As you can see, if we go and look at our IK things, no, I'm not going to make a metaverse. Although, this sort of stuff does help with that. I've got a target override for the left and right hand, and the idea there is that if I want to, for instance, move my hands based on my controllers, or I want to move my hands based on an in-game thing, I can just create a node 3D here, and I can say left hand target, and now I can go to my avatar, and I can go to my hands, and I can say my left hand becomes my left hand target. Boom, and that's obviously in a really bad position right now. Oh, and I need to reload that because we did some things with avatar. So this is one thing that is a bit of a problem when we create these when we change these tool scripts, sometimes Godot does not reload it properly. So now you can see that actually my left hand is properly positioned now. Sorry, my right hand. And my left hand is now positioned based on my target node. But you can see that I do need to rotate that in position to do something useful with it. But the idea here is that if I have my override set, then obviously, I can change this position any way that I want. Yippee. So I can have some fun with that. What is it, Mao? Not Mao. So yeah, so the whole idea is that the default logic of my avatar will just put the hands and feet in default positions. And obviously, because I don't have trackers on my feet, maybe I will enhance this to eventually also have overrides for that. But yeah, you can set those on the avatar, and that means that it's no longer using the internal target. It's now using a target that is external to it. And again, the magnet isn't set up the best, but yeah, there's some things that can be improved there. Anyway, with that done, we can see that yeah, our hand is moved there. And obviously, because I've made it a child of my avatar, the target is rotating along, and that keeps working. But you can see that as I move my body, the targets are obviously keeping the hands where they were, and the arms move around. So pretty damn cool. And drink water in. I'll keep on drinking water in real life for now. Okay, so that's the first thing. So now we're going to start looking into actually making things animate. And as we can see, we have two groups for that. We have our hips and we have our leaning. And these are actually coming from, and I'll just quickly put this. I'll put these links in the description of the stream later on. But I found these little articles on locomotion, part 1 and part 2. I'll just quickly open part 1. This is a Unity, I think it was Unreal, can't remember. But I got this because the guy who wrote this blog has got a pretty good video online where he does actually something much more. But he's explaining, some stuff on locomotion and doing it standard, or doing it, what you call it? Doing a procedural. That's what I'm looking for. Word. And I'm at a point with it right now that, it does some basics, but he's now explaining how he's doing the walk animation, and I actually don't like what he's doing there. It's too simplistic. So that's where I stopped, and I thought, let's continue where we were, and then play around with that and see what we can do. All right. So we have leaning and hips. So I'm going to turn hips off for now. I'm just going to deal with leaning at the moment. And the idea with leaning is that depending on how fast we move, so if we move backwards or if we move forwards, you can see that we are leaning backwards or forwards. So if we're moving backwards, we're leaning backwards. If you're moving forwards, we're moving forwards. And the same side by side. If you're moving side, and that. Now it's overpronounced right now. It's too much. But the idea is there. Now the whole idea also is that the faster you move, the faster you move, the less that angle is. And I think there's actually a bug in there. Hey George, how you going? So that's something that we need to fix up. That's definitely something that is a problem. The other thing with the leaning is that right now it's too overpronounced. So I actually had in my other little demo, I had already toned down a number of these settings, but we need to play around with them some more. Now, the idea behind this is that if you start walking, the first thing that you do when you move forward, when you walk forward, is you lean into it. So it's basically the way that they describe it is you start falling forwards, and in order to catch your fall, one of your legs, either your left or your right, depending on where you start with, is going to step out first. So we've got the leaning now, based on the acceleration, and now we need to do the leg movement as part of that. The other thing which we have, and I'm just going to turn that leaning off and just turn the hips logic off on so that we can see what that's doing. This is making, and we can see that everything's going a bit weird. But this is, first of all, making our player bob up and down, and we're swinging our hips a little bit. Now, I'm not quite sure why the feet aren't staying on the ground. Because the feet are supposed to move with those. So, is that okay? Not on right now? Could be. Hold on, let's go and reopen that. We might have screwed that up. Yeah, so now we can see the feet staying in place. And especially sideways. Yeah. So basically we have an up and down motion, and we have, and it's hard to see here, but that's actually one. Let's actually turn these both on before we forget. We'll turn it off in here. So the hips are on, but let's turn the leaning off. Oh, this one. Probably should make everything a bit lighter, but you can see that bobbing. Oops, I'm too far. Come on, walk back. There we go. You can see the bobbing, and you can see the hips moving a bit left and right, which I did put a nice little animation on my YouTube hidden video, or unlisted video, because the first time I saw this, it's so overpronounced. Couldn't help laughing. It's funny ass, but hey, it's a start. And the thing is, obviously, we're going up and down, and we're doing our hips sort of going swaying like that, and the swaying is about half the frequency of the up and down. So for every time that we sway, we've gone up and down twice, which means that we go up and down one time when our left leg or left hip is up, and we're going one time up and down when our right leg is up. And we need to sync our walking with that. The other thing, of course, is that the thing is moving along, also based on the speed. So if we go a bit here, okay, that's so far. And if we run, why don't we run? My run broke. Come on. How do I turn sticky keyboard nonsense off? Windows, sticky keys, turn off. Settings. All right. Okay. Here we go. So it says ease of access. Where do we have ease of access? They changed it. Of course they changed it. Why would they not change it? Why would they not keep it the same so that our help actually works? Settings, ease of access in the left. Oh, maybe. There we go. Ease of access. We still don't have an ease of access, but maybe it's an accessibility then. Keyboard. Audio, keyboard. Sticky keys is off. How can I tell it to never ask me for this? Keyboard shortcuts. No, this is my problem. Press shift 5 times to do this. So if I want to use shift for running and I press it 5 times for running, then my sticky keys thing comes up. I do not want to see that. I've never in my life used sticky keys. Lock shortcut keys when pressing twice in a row. No, definitely do not do that. Turn off sticky keys when no 2 keys are pressed at the same time. Yeah, sure. Turn it off whenever you can. Play a sound when shortcut keys are... that's fine. Okay, let's see if it now stops bothering me with the sticky keys. Okay. Shift. Yay! I am no longer bothered by the sticky keys message. Hey, cat. What are you doing? Why are you meowing so much? Hey? Hello? Are you going to run away from me when I do this? Push it there. She doesn't like to be picked up. Sorry, else I would show my cat. Yeah, I hate sticky keys. So I finally have sticky keys off. Aha. But my run suddenly doesn't work anymore. Why did my run stop working? Oh, she suddenly jumped up. Say hello. Say hello. Hey, say hello to everybody. Say hello to everybody. Say hello. 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 Yeah, I know you're really being annoying tonight. Yeah, you hear me talking, and you go like, "Why are you talking? Why are you not talking to me?" Hello. Normally she wants to run away from me like in 5 seconds. Now she's actually going like, attention. I want some more of this. Hey. See, it's not so bad being here. I can't keep you here though. I need to do my stream. And you're keeping me away from my stream. Hello. Hello. All right. Meow meow. There we go. That was my cat. All right. I thought we had our. We've got run speed. Oh, maybe because sometimes it does that when. No, run speed 2, 5. Action pressed is run, but that's good. Oh, my key went away. I must have done undo one time too many. Okay, save. That is also something that happens when I undo a couple of times because I want to reset my changes that I'm just doing for testing. Sometimes I do an undo too many. Okay, so yay, I've got the run working again. There we go. All right, cool. Cat, what are we doing? What are we doing? Okay. All good, DK. Well, Rod, you're joking there, but she actually she jumps on my desk to get on top of my computer, which is on my right, and obviously my keyboard and my mouse are quite close to my computer. So every time that she does that, and she does that suddenly, she will jump either on my mouse or on my keyboard, which is really really annoying. But hey, I love my cat. She's wonderful. But yeah, she can get in the way. All right, so let's have a little bit more of a look at exactly what this all does. See if we can figure out if there's indeed a bug in that leaning, and then we start on our walk animation. So obviously our hips are a little bit overly pronounced, so I'm going to change my amplitude down a little bit. I'm not a girl. So, oh. You guys couldn't see that, but my cat just jumped on my on my desk again. What are you doing, cat? Okay. That's just how fast the animation changes, and that is the factor is sort of like the factor between the movement speed and how fast the animation is, and that one felt kind of good. So let's see if these settings work a little bit better. So we still have quite a bit of up and down. I need to make sure that my camera doesn't move through things, but actually, before we do anything else, let's go in here. Let's go in directional lights. Just for now, I'm just going to put my sun up. Obviously, the whole idea is for this room to be... Actually, that might not make a difference because we're inside and we're in shadow. And now I'm starting the wrong scene. Here we go. So I don't think... Oh, we got some sunshine coming in from outside. It's kind of nice. So we can see a little bit better what's going on. I still think that the bobbing up and down might be a little bit too much, but we'll see how that goes with once we have the leg thing going. And we can see that if I press shift, it all goes faster. And it's a direct relationship, and that's fine. Okay. Cool. Okay. All right, so let's go and see if we can get that leaning to work correctly. I actually like these default values. So what did I change? I set that to 0.5 and that to 10. So I actually want to have those as my default. Cat, what are you doing now? You're going to lie in front of me again, huh? Yeah, it's fine. You can lie there as long as you don't sit. She likes putting her butt in the air and then so right in front of where Godot is. So I can't read my screen when she does that. But she's lying down now. So we've got our amplitude. That needs to become 0.5 as a default. And we're going to go and make that default 10. So that's good. All right, cool. Now for the test, let's go and just do my leaning and turn my hips off. Let's see what that looks like. Oops, didn't mean to do that. So we got, that's way overpronounced. That's kind of okay. Okay, so this is weird. Don't know if you guys saw that, but when I move forward, I bend like that, and then when I go faster, it actually does less. So I definitely have a problem in the code that does that. So let's go have a look at what we're doing here. I'll eventually make this code available, by the way. Probably not in this project, but I'll make a little test project that you can walk the avatar around a test scene and put that up somewhere. And I'll probably add a whole bunch more documentation here as well. So that's all the IK stuff. I get my hips bone and my spine bone. What are you doing now, cat? You're gonna throw things on the ground to get attention. Yeah, love doing that. So I'm getting my hips bone and my spine bone. So when we go and look at my avatar here, my hip bone is that one and my spine bone is that one. So obviously when we are doing that sway, we don't want the whole body to sway with it. So the amount that we sway the hip bone, we unsway, so to speak, on that one. I heard a rumor, cats, will give you a reminder you need to take a break from the computer. If that was true, then I would never get any work done. But yeah, they can be wonderful. What's the word? Wonderful distractions. So that's why I get those two hip bone IDs. All right, so everything for my animation I'm actually doing in my process step. And this is the first thing that we need to look at because this might actually be where our problem lies. So I am starting with calculating my velocity. The article that I pointed to that I was using as a base was actually using the acceleration, and I found that was a problem. That wasn't working properly for some reason. Anyway, our velocity is calculated as our current position minus our last position. That is how much we've moved in the last frame. And then obviously we are dividing that by delta to actually get a velocity in meters per second approximation. So this velocity vector should be higher depending on how fast we're going. Let's actually go and prove that. The way that we're going to prove that is we're just going to do a label here. So this is obviously going to be a label that's going to be displayed over here, just in our screen. This is a nice thing when we're not doing VR, is we can do these sort of things. Dot text is 0.2f. I think 0.2 is probably good enough. And actually, I do not care about my about my vertical velocity. So we're just going to say velocity.x, velocity.z. We're not going to print our y velocity. Cool. So we can. Okay, I am actually just going to. Oh, what are these? Note I found debug relative to. Oh yeah, that's again problem when you're doing stuff with with tool scripts, when you do changes like that, the version in memory does not have the changes yet, and therefore you're getting nice little errors like that. Yay. So I'm just going to do a select current on that so that we actually open that scene. Just for now. All right. And of course, my thing was in the dark, or in the light, so I couldn't see it. So, -2, 2, that seems to be correct because we had our normal speed for 2. So it should now be that if I hold shift, that should go to 5. Look at that. 5, 5. And sideways as well. Actually, I want my sideways speed to be different, I think. I'm going to go and do that as well. It's going to be my character body. So we have a movement speed. And we're actually going to make that a vector 2. And I'm going to do the same with my run speed. So we're actually going to have a different speed forward and backwards as that. And that should still work. Movement is a vector 3. This is now a vector 2. So this actually I actually need to do that with my input direction. No. I think the X and Y are probably going to be the wrong way around. Let's just do input here times equals that. Okay. Hey, Ralph. Nice to see you as well. All right. I think our X and Y are now going to have to be. Okay, that's so. Because left and right is X and forward and backwards is Z. Okay, that's weird. Why? Oh, because I'm normalizing this. I don't actually want to normalize this. Why is that normalized? That doesn't make sense to normalize that. Because the input there should already be between -1 and 1. And on a analog joystick, you actually want that, if you, we actually probably want to do, proper analog input. You don't want to normalize that. So let's take that out. And now, we're still going to go slow in that way, but we're going fast in that way. So that indeed, that proves that this needs to be the other way around. So that's 2, 1, 5. Okay. And seeing we're doing that on our inputs, that should then, so we're going forward. Okay, if we run, we can go faster, but we still go slow with that. Okay. Anyway, the most important thing here is that our velocity is showing the correct information, but we can see that we are when we go faster, we actually have less of an angle, which doesn't make sense. Okay. So now that we have that working correctly, figure out the next step. So our velocity is cool. So is it then a problem with what we're doing here? Well, let's go see what we can make of that. Oops. All right, so we actually want to have, that's going to be our main vector. And obviously, as one X. Oh, Y, I mean. Go. So. Oops. So we can see that our lean vector, you probably visualize that. I might want to visualize that. Okay. Yeah. I think that's okay. All right. I think that is actually doing what it's supposed to do. So now we're getting our strength, which becomes our length. So that will be 2 for normal 5 if we're going faster. And then we normalize that one. So now our lean vector should become 1 in length, which is exactly what we should be doing. And then we have our lean angle. So here we are doing lean factor divided by lean strength. Is that correct? That does not make sense. Let's see. Because that would indeed invert it. Just having a look at the original implementation of this. Okay. Yeah, that should be times. I'm not sure why I did the divide there. That should always have been times. All right, see if that now makes sense. Maybe, but it is not enough now. It kind of makes sense. Did we change anything with this? No, it's still the standard 0.5. Okay. Of course, they're using a magic number there. Oh, yeah, that's right, because I had trouble with that. I did a degree rad on that. Although no, that they did that too. So that's correct. All right, so let's go and put that in. Actually, yeah, I'm gonna move that over here so that I can do. I'm actually just gonna comment that out. Don't actually want to remove it just yet, in case I do need it. That's an extra bracket that we need. So here we're gonna say lean angle. I can't see my stream. Oh. All right, lean angle. Da 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 da. Let's go and put that in and see if that makes sense. So we're doing the value before we convert that to radians. So that means, why is it still showing? Oh, that was just some default value that was left over. Well, that is way too small an angle. That was my enter key, Cat. You're lucky that I haven't got my enter key bounded or anything in my game. As I was telling at the beginning, my cat loves jumping on my table and loves jumping on my keyboard first. And now she is lying on my computer because it's nice and warm. You love it. Yes. I need a cat cam. Okay. What are we doing wrong here? All right. So we got our lean strength. That should be 5. So is our lean factor something that I've changed to something it shouldn't be? No, 0.6 is what they used here. I have a feeling that the divide by 100 was done to bring this into line with radians. That's what I'm guessing. So it actually makes more sense to me to just do that. I think that's just a bug in the example. So, well, that's still a really tiny angle. Well, the other thing, of course, is we're doing everything in meters per second. Maybe they have a different... Okay. A different thing there. Okay. So, let's go. And let's make that 2. And see what it does. Well, we got a little bit more leaning. Let's make that 5. This is trial and error, obviously, to get this to a value that makes sense. Okay, so now we're getting to a 10-degree lean angle for normal movement. And for running, we go quite a bit. This might be a little bit too much. Obviously, the left and right leaning is only a little bit. For running, we're going quite a bit forward, but I kind of don't mind that. And for walking, we're just going a little bit. So that makes much more sense to me. Okay. So now we're leaning into the movement that we're doing. Cool. Let's turn our hips back on and see if the whole thing makes sense together. All right. Okay, and so our up-down is way too much. Our hip movement, I don't really care too much, but our up-down is definitely way too much. Now, I thought we had made that less. So my guess is that we have some default values messing up. This is a downside that I have run into before, where sometimes when you've got scenes open, when you change your defaults here, especially on tool scripts, it sometimes remembers the old values that you had there. It doesn't realize that you've changed stuff underneath. Okay, so we still have our up down. Why are you? Sometimes it's getting stuck. Oh, it's stuck again. What's going on here? Huh? What's wrong with you, thing? It's like we're not getting our keyboard commands in there. I think my keyboard is misbehaving. Might be losing. Maybe my keyboard is running out of power. That's possible. No, it's working now nicely now. We might need to do the bobbing a little bit less still. I think it's now 0.05 is 5 centimeters up and down. But it might be something that we won't know until we actually have the feet moving. So now we're going to figure out how do we move the feet. And that's going to be tricky. So if we look at our character here. Basically, what we're doing. Oh, no. That's good enough. Is when we start moving. Why is. Come on. Don't save. Annoying. Okay. Yep. IK is working now. Sometimes it gets stuck. Let's do it. Yeah, good enough. So when we're moving, we're basically, and I can't really do this very well here, but we're kind of moving our feet like that, and then we're going down. So we have one foot that is on the ground, and we have the other foot that is moving like that. And actually, this foot at the same time is, that's not the feet. Not quite sure how it manages that. This foot would be moving back as we're moving, up until a point where we're at the maximum. And at that point in time, this foot should be on the ground, at which point in time, this foot takes over and moves back until it can't, and then it sort of makes an arc going there. Boom. Okay. Moonwalk shoes, but natural, something like that. So the bottom line is, for our movement, we always have one foot on the ground. So one foot, we just keep our target where it is, and then the other foot needs to move. So we need to figure out how much we move forward in that step. And obviously, when we start to run, we're eventually going to have to figure out, okay, how can we make make it so that we have a moment where we're actually, quote unquote, flying through the air. But we'll deal with that. We'll figure out how we deal with that. So, all right. So one thing that is important is that our hip movement, that factor, is basically what decides how much time we have for one part of that step. So the duration that one foot is on the ground. So like I said, that factor is what does the up and down movement, and then the hip swing is off of that. Every hip swing, we need to take, switch the foot. Let's put them on the unicycle. Okay, so let's go and have a look at our hip logic, because that's kind of going to determine which foot we're going to keep on the ground and which foot we're going to move through the air. Actually, one other thing that we're going to do is we're going to store what our last foot position is in global space, because obviously the foot that's on the ground, we want to keep that where it is. All right, so last position, last velocity. We actually don't care about that anymore, but we'll keep it. I might want to group this a little bit. Yeah. Okay, so let's put that over here. So we're going to last left transform 3D, and we're going to keep our last right transform. That's going to be like that as well. Okay. Cool. And what I actually want to start with is the part where the feet are on the ground, so that we're going to swap. I'm just going to, leave the other foot alone. I'm just going to drag. We're going to make that the foot that should be on the ground. We're going to keep that one on the ground. We're going to start with that. Also means that we're going to go at the end here. Is oops. Left foot, double transform. And I'm gonna keep that to the default, even though we might at some point put a note here to do if we ever override our feet targets. We may need to get. but we'll never do the overrides logic. Obviously, if they're overridden, we are not going to have our movement there. Okay. So we're obviously going to do that in sync, but I do want to do an enabled group for that. So let's make a new group here. Export group walk, boom, and then export var walk enabled. True. Are we doing our walk animation? Oops. Wrong place. There we go. Cool. So if walk enabled. What the has pass. So we want to do that same logic for our hips offsets. All right. This must be in sync with our vector. With the hips. Oh, because we have already calculated this. I'm just going to do yeah, just in case our hips are turned off, we calculate again, but basically we shouldn't have to do that again. And really this one, I kind of want to move that over to here. I know the name is probably not too smart, but oh, why? I've already calculated that. Why am I calculating that again here? That's dumb. Here we go. Which means that I don't need to do you. I do need to do you, and I can just do you. Boom. Okay, cool. Because when we are not moving, I'm going to do an else here. Move feet back underneath the layer. And we're gonna deal with that at some later point in time. Okay. So here we need to switch between which foot is on the ground and which foot isn't. How do I want to do this? Okay. we're actually not going to recalculate. We're going to calculate it slightly different. This should be in sync. Oh, that's a plus. It's so we couldn't do that. So, you know what? We're just going to say and hips enabled. And that means we're going to add in a func get warnings, get configuration warnings, or warnings array, run warnings. If actually no, I'm going to do that differently. What I'm going to do instead is I'm going to say, oh wait, if walk enabled or hips enabled, and velocity is bigger than 0, then we're going to go and do this. So basically, we're always updating our hips offsets, even if whether we are doing our hips or we're doing our walk. Okay, cool. So that means that we can now always use our hips offsets. All right, so all right. If hips offsets smaller than now, left feet on ground, else right. Actually, foot, not feet. Foot. All right. All right. Okay. Bar on ground. No 3D. Bar off. Foot on ground. Foot off ground. 3D. All right. Foot on ground is default left foot. Foot off ground is default right foot. Assuming that's not the other way around, but we'll see. Okay. So that's the other way around. Now, just to be paranoid, I can't see my screen. Hello. All right, so in a run situation, we're probably going to do something a little bit more. And the other thing which is nice is because we're doing a target, even if we are if we're moving away from there, let me think this through. So if we're moving fast enough that our foot is still, or it can't reach the ground because we're moving too far ahead, the IK will actually move the feet slightly off the ground, which is kind of cool. So we are going to simply do dot global transform, and I think I've done that wrong at the end. Did I do that? Yes, I did do that, right? Oh. Okay, so I want to do this differently then. No, I'm going to have to I'm going to have to put the duplicate the full logic. It's a shame, but it'll have to be. I'm going to keep it where it is. Keep our targets where it is. That's going to be this one. Position, right click. This then becomes right foot on ground is last. Right transform. Because remember, our character is moving forward, so everything is a local space will move with it. We actually want to put it back to where it was. Now, the fact that we're doing this in process might be a problem. We might need to do this with a little bit of logic somewhere else, but let's just see how well it works. So in this case, we are not doing that. We are not doing that. But I am going to leave this. Oops. Now position left. All right. Cool. Sweet. No. No. All right, and that's right foot, left foot is going to be more challenging. But we'll deal with that in a minute. Okay. So there's actually one more thing that I want to do, and for that, I think I need sprites. You have a circle. Okay. Download the circle. Why is... It's a circle, guys. Okay, you know what? Go away. How the hell can you CC for a circle? Really? What is that? All right, Krita to the rescue. Here we go. File. No. Oh, that was actually the right button. No, we're not creating it for clipboard. We're just doing a circle 256 by 256. RGB alpha content should be completely. That's correct. All right, cool. And now we're going to draw a circle on this. The circle is going to be white. Nope, that did not work. Why did that not work? Circle, opacity 100, made it white. Yeah, exactly. Okay, do I need to do a new layer for that before it will paint the circle? No. Is the circle not the right? No. What am I missing here? What am I doing wrong? I just want to have a simple circle. Why doesn't it draw the circle? Got it white. Oh, maybe I don't have the right pen selected or something. Basic. Okay, that's close to what I had in mind. I just don't want it so big. And we probably want to make it something like... It's not an exact science, but we have a circle. Yeah, I am breaking copyrights left, right, and center. Very sure about that. Just make that a PNG, PNG. And this is in project schemes. Is it? No, this is in YouTube. Sort of. Go for it. Alrighty. So, left foot, 3D over there. Very cool. Plus, mesh instance, oink. Make that a, where are you? Plane. Am I, oh here, I'm blind. That is way too big. 0.1, 0.1. Probably want to be a little bit bigger than that. 0.2, 0.2. There we go. Yeah, that's good enough. Material. Standard material. This is going to be unshaded. This is going to have that circle. Go. That's because I haven't got transparent on. Alpha, there we go. All right. I might actually want that to be slightly up. Oh, that's of course. I made that a, yeah, there we go. Yeah, that's good enough for what I want to do right now. I actually want this to be even slightly bigger. Get it very clear where it is. Okay. Material, color. I don't know. There we go. Green. Perfect. All right. All right. Copy that on my other foot as well, but here, actually what I really want to do is I'm going to go and grab this. That's a mesh. It's material. I actually want to copy this material. And I'm going to put that onto here. And now I'm going to go and clear this. Okay, that's cool. So what I've done now is I've removed the material from the plane. I've moved it onto the mesh instance, which means I can now copy this onto the other one. Now I can say make unique. And with that, I can change the color of this so that we can clearly see which one's which. And when we go to our test, we should see our circles there. Cool. All right. So we've got the foot that's on the ground through the whole process on when it's on half of my animation. That one is going to be staying where it should. The other foot is going to do dumb things. It's going to just drag along. But it will show us. Ooh, why is that target over there all of a sudden? I don't know. Okay, we have a problem. Okay, so that is not working the way that it should yet. All right, so we are. Do we still have our little debug thing? Yes, we do. This needs to be initialized on the first. That's why this is going wrong. However, I want to go and do this and say offset, just so that we have something to display. But the thing that I forgot is we need to get initial values for this in our ready function. Yeah. Let's see if that makes a difference. Okay, so now they're in the right beginning position. Okay, that's almost good. Oh, because now, yeah, because we're not resetting where it needs to be. We can also see that we're okay. I think I'm rotating this by 2 pi, but actually I'm just doing sin and cos. So this should not be tau. This should just be pi. But the problem is that we never decide what our new position is. That looks better. Okay, that looks better. So let's go and do something with our other foot. All right. Kind of funny. All right. Yeah, the foot pointing and all that sort of stuff we're gonna deal with as well. You know, one step at a time. Cool. And the other thing is that here it's nice that we won't know or we won't care about that. So that's cool. I'm actually going to keep a helper for that. We should put an enum there, but I don't really care. There we go. So now oh, what? No. There. So now the trick is going to be, okay, we need to, whatever foot is in the air, we need to figure out where we want that to go. All right. And what I'm going to do first is I'm going to snap it there. It's going to look weird, but that's fine. But eventually we're going to make a nice animation for it to get there. Let's first get the snapping done. All right. So that means okay, this is another problem that I have because this velocity is not altered for delta. Okay, and that means that this is now not okay, so that means that our hit factor is actually really wrong. Okay, so we're at 60 FPS right now, and that seemed to be okay. So this actually should be 6. All right, let's see if that makes sense. If that's still, yeah, that is to be. No, it's not. Oh, is that because we? Yeah, of course it is. Let's go and close you. Let's go to you. Let's go to you. There you go. Oh, that's the range between that and that. Okay, so that's going to be a bit less. That's going to be a little bit more. Tick, tick. That's better. That's better. Let's see if that now makes sense. Okay, cool. All right, so. right. Oh, I'm on. Yeah, so the right thing. Okay, so. Make target transform. Don't worry, we are going to make a function out of that in a minute. We're positioning our right foot, so let's go and have a look at. Oops, I want to be in there. Right foot. 11, 15, okay, so. So for our walk, we're going to say we have no, export bar walk foot offsets. Float is, I'm just going to use that 0.15 for now. Foot offsets. Okay, right foot is negative, left foot is positive. So this is going to be a vector minus walk foot offset 0, 0. And this is going to be with a plus. And the reason why I'm putting this into a temporary variable first and then assigning it here is we're going to do a lerp and offset thing here. Yeah. But for now, I just want it to just snap there. Basically, we're going to calculate where we want the foot to land when we start stepping on that foot. All right, time to make a function for that. Okay. All right, so for transform. No, let's not do that because we are going to be. Let's write it out fully. It's that. And we're gonna go and return that transform. Okay. Change to global space. Is global transform times that one. To raycast to see if down. Cool. All right. So we're going to start with stop with that. But origin place it at our offset. Move it in the direction of movements. Okay, so this bit is going to be tricky. Okay. So we already have set our last velocity. That's actually kind of cool that we keep that. We actually don't care about that anymore. We're just going to go and put that together. Although maybe I'm just going to give that to our function as well. I think that is probably better. Okay. Let me think. So where are we going to be putting that? I think we're going to be putting that because we are moving from half our time forward to half a time backwards, or actually quarter forwards, quarter backwards. So we need to calculate our velocity times the amount of time that we would spend moving forwards, and that is obviously where are you? This calculation here. So here we're kind of doing the opposite calculation to this. So here we're getting our velocity times our Hipps vector times delta. And we're rotating that by pi of my tau. So I think that is going to become velocity times Hipps vector times half. I think so. It could be quarter because I'm not quite sure. Why is this all? Make target transfer not velocity. Yeah, this is p velocity grid. Okay, so vector 3. Thank you. Same sec. Okay. Let's see if I got that right. I'm not entirely sure, but I think I am. Oh, no, I'm definitely not. Okay, that was funny. All right. No, the problem is I need to know Hipps vector times delta. Oh, hold on. God, this is doing my head in. How am I doing this? Oh, haha. So, yeah, right. So delta is actually, because this is a cumulative thing. So when we've moved 1 second, the total distance that we've moved is that times that, but we're breaking it up by pi. So the question is, yeah, so hold on. Come on, last thing. What am I missing here? What am I doing wrong? So how much have we traveled? think. Yeah, because one iteration of this is actually 2 times pi. So, because that's when we rotate. So that's, so we now need to do that equals pi. How far have we traveled in that time? So this gives us a duration. So velocity times his vector is pi. Come on, I'm getting tired, guys. So if so we need to know how much time before we get there. All right, so times t is pi. Okay. And we need to know, in this case, we need to know t. All right, so t time is pi divided by this. So now we know the length. This is the duration. This is the duration for one cycle. And we actually need to know half this. Okay, that's cool. So now we need to know the distance that we need to travel. So this will actually be, so our final distance is times t, which then therefore becomes that, oops, which becomes that. Okay. So does velocity now cancel each other out? I think so. I think our distance is going to become 0.5 divided by Hip's vector. Sure. Let's try that. That means that we never actually use that one, which would be interesting. Oh, that's interesting. That works. Oh. Okay, I'm definitely making a mistake here. So velocity times Higgs vector times time. When enough time has passed to get to 0.5 times pi, that means that we're doing t is pi. Yeah, that's correct. So now we know. Oh, but of course we need to do that with the length of velocity. Okay, so we cannot avoid that bit. Okay. We need to write it out fully. Okay, so that actually needs to be length. This as well. Because remember, that's why we're doing velocity. Yeah, it was the length velocity. So now we get distance, and that is length velocity. Okay, so this is going to be velocity length times Hip's factor. Okay. Is it happy now? What am I missing now? Oh, missing the times. All right, is that working? I don't know. Okay, that is Okay, we're not switching between things. So I messed something up in the switching code. Hips offset is smaller than pi. Oh, but I think I better. Where are you? I better do this -2 so that it actually is switching nicely. Okay, this is weird. Why? Oh, because offset keeps. Hips offset. Which one am I? Oh, ha 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 ha. Of course. Plus. Da 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 da. That's what I'm doing wrong. Okay. Yay! Okay. All right, so if I does it increase or decrease in factor? Let's increase the factor. All right, you know what? I'm actually going to make that settable. Okay. Yeah. The colliders and stuff are eventually going to deal with when, first of all, to decide where we want to put the foot down, and second of all, indeed, the angle of the feet. Yeah, but I first want to get the actual base animation in order. So let's actually do a bit of real UI work. So vertical box debug UI. A box. Okay. That's going to be debug info. Oops. Plus label. Actually, let's make that. Okay, so the pi is kind of a it's kind of a happy accident, right? So when we're looking at the character moving in a direction, we move a certain distance for one step, and then we move the same distance for the other step, and then same distance for the left foot, same distance for the right foot, same distance for the left foot, same distance for the right foot. That's the pattern of walking. Now the thing is, you're moving at a certain velocity, and I've already made the code that as I'm moving forward, depending on that velocity, I'm also bobbing my character. I'm going up and down and up and down. And that up and down logic is controlled by, where are you? The hips logic here. So we're just moving that hips offset forward. So this is the real speed calculation. That is the thing that decides how quickly we go through our walk cycle. But in order to do that up and down movement, and in order to do our little hip sway, we are using a sine function on that. And obviously the sine nicely repeats, one up, one down, one up, one down, etc., etc. And one of those cycles is 2 times pi, right? Because it's a circle. So pi, and then the other side pi, pi, pi. So that is why I'm doing an f mod here by pi, so that basically I go to the end of the sine and then I go back, and I go through the sine and I go back, and I go through the sine. And that's how my amplitude and sway nicely work. The reason why I originally had pi times 4 was because I wanted 2 whole cycles, because I'm doing this. Now, actually, because I'm going times 0.5, I might actually have already screwed that up. We might now just have a sway like that. So I need to figure that one out. I might actually have to do an extra F mod there. Actually, let's check that real quick. Well, let's do this thing first. Let's go and put that in there. We're going to call that info. And now I'm going to go and say for debugging only, unready var debug info label is debug info. There we go. And now debug. Just in case I ever want to get that back. Just in case. Fmod is basically, when you do a division, so let's say that you do 5 divided by 2, you get 2.5, right? So if you want to get the integer part of that, you get 5 divided by 2 is 2. And Fmod gives you the remainder. So it's basically the remainder of a calculation. So 5 divided by 2, or 5 Fmod 5, 2 gives you 1, because it's the remainder of that calculation. Is it 1? I think so. Or half. Always forget. Yeah. So basically, it just means that if our whole cycle is 2 times pi, then our f mod 2 times pi means we go from 0 to 2 times pi, and then we go back to 0, 2 times pi, even though the actual value goes further. Graph toy. Ah, that's really cool. I need to bookmark that. All right, so. All right. Can I clear that? Yes. Cool. So we have one example. All right. We actually, in this case, don't care about time. We care about x. So if we do sin x, you see that there's a sine wave. Well, let's keep x in there as well. How does it? Oh yeah, enable 1. So we got x. That's our value. So that would be our continuously increasing value. That becomes a sin. So if we now do, I don't know if this has an f mod. Let's see if it knows that. No, it doesn't. I think it's percent 2 times pi. Oh, 2 times pi. Ah. Okay, interestingly, it doesn't do the negative 1. That's always interesting, that actually for negative you go on the other side. It keeps the value there. So I really want, can I? Yes, I can. There we go. So here you can see, I'm actually going to turn that off. We can see that our, no, not that one, that one. We can see with our sine x, we can nicely see that we get that sine wave. And with modulus, so this is f mod, the percent sign, we can see that we go up and then boom, back to 0, up, back to 0, back to 0. And by doing it that way, we make sure that our value stays between 0 and 2 times pi, which we need for that. That's really what we need to do. This is a cool page. I like this. Got to keep that in mind. I hope that makes it somewhat clear of what we're doing here. All right. I just wanted to quickly see if we broke our sway. Can't really see it. Let's disable our walk. Funk avatar. It's the same one. Walk for now. Why is that? No. Ah, that definitely is a problem. All right. Damn, it's too dark. Wait, what if I? Yeah, I think we just broke our sway. And that's all right. Although it might mean that we actually need to. Yeah, we might have done that wrong. So I do want to keep that on 4, which means that this actually needs to be 2 times pi. And I think we don't have our 0 there. We just have our. I'm going to remove these comments eventually, but all right. Let's see. So we don't have our walk enabled. I purely want to see if my sway. So yeah, now my my sway is good again. So we have one. So basically, in there we can see. Actually, let's get a graph toy again in a minute. So we now have. Where are you? Dang, I can't see it. All right. So we now do this. So imagine for a moment that that is x. So we're going to do pi times 4, and then we're going to go and do the sin of those two. So let's see what that looks like in that graph toy. All right, so I'm going to go and delete this and delete this. That's good. Oh, and keep that on x. So I'm actually going to go like, no, we want to make sure that we can see that. So this is our progression of moving forward, because that's basically what we're doing here, right? Is we're calculating based on our velocity times a factor times delta. So this is basically how much are we moving forward. We're doing that as that. So now we're going to get our x modulus 4 times pi. So now we're going to see, oh, no, that's not the times, that's a modulus. Can we? Yeah, we can. Cool. I'll zoom out a little bit. So now we can see that every 4 pi, we can't really see nicely the values there, but 4 times pi should be 12 and a bit, almost 13. We can see that. That's 12 a little bit. We're going there. So now, if we take that one again and we do sin, not sin, sin that value. I wish that we could. Can we grab the previous outcome? Can we do? Let's see if it actually takes that. So actually do that for this one. Sin f2 times 0.5. Can we do that? No, it doesn't like that. No. It'd be so nice if we could just. No, I can't do something like that. Okay, so I always need to do this. That's a shame. Oh, look at that. Oh, all right. Cool. So we're seeing that our up and down keeps going like that. So we have 1 up, down, 2 up, down for every sway. So here we're swaying to the left. Here we're swaying to the right. This is the distance that we step forward, and then we step on the other side. So yeah, Nice little toy. So we got that correct now. We got that correct now. Walk is enabled here. Cool. Let's go and enable our walk again over here. Okay. That's not 2 times pi. All right, let's see if I did that correctly. Okay. Oop. No, it doesn't seem to be. Okay. I think it might be because we're going negative. I think F mod here is allowed to go. Actually, that it should show me that. Does it go negative as well? No, it doesn't. Come on, go away. Sorry, guys. I'm just looking off screen on what the offset is being reported when I'm outputting this. Okay. Oh, it doesn't do the dash n? Really? It's supposed to do that. Okay, one thing that's just really strange is why is my target starting all the way up there? Where is that coming from? I haven't walked yet. Although I do have my info right now, which is interesting. So, velocity 0. Well, one way that I do know that works is this. Oops. Okay. So yeah, it says left foot on ground. Our offset is already slightly forward, which is weird. Yeah, we're only doing this if we actually have a velocity. Last position. We actually need to have this in there as well. Last velocity, even though we're not using that. Oh no, this is going to be always vector. Oh yeah, that's the default value for that, so that's not a problem. I just want to keep those together. Why would it already have a velocity to begin with? The very first time, our last position is our global position. Our global position doesn't change, so that should be 0 divided by delta should still be 0, so we should have 0 velocity. So where is our initial value coming from? Okay. Start with that. I think that I might have to do. No, that should have no velocity. So why do we have that initial value? Where's that coming from? Actually, the fact that it's going up makes me think that it's up-down velocity. So when it comes to our avatar, take our full velocity out of there. Oh, but this is okay. So we're gonna change that. Are we? Because if we're not moving on a flat slope, I'm not gonna worry about that right now. But I do think that this is probably because we're probably falling or something, or it's adjusting this on in some way, shape, or form. Has to be something like that. I don't know. Very strange. So no, I'm not going to do this. Because eventually when we're standing on the ground, we're going to move our feet back under our player anyway. We might actually want to do that right away. For now, just reset. Oops. Is transform 3D bases vector 3 okay, there we go. Cool. All right, that puts them nicely back on the ground. Sweet. Okay. Okay. Oh yeah, that's why I wanted to create that UI. So what I think is happening there is that we're only doing half of our walk cycle before we reset the feet. So we're going the wrong way in flipping our feet around, which could have something to do with what we're doing here, but not entirely sure yet. Could also have to do with our distance calculation that we're actually not moving far enough. Maybe that 0.5 was correct here. Actually, let's just assume that that was correct. That does kind of look correct, actually. All right. So the thing that I now wanted to do is get my little UI thing working. All right. Let's keep that in. And that's right, because that goes every, I don't know. It seems weird. Okay. Why is it? Huh? Why is it offset like that? Okay, something definitely wrong there. Oh, I forgot to check that. Oh, that's right. Okay. Hmm. So that is local. Look at that. Let me make it global. And return it. Oh, because our velocity is in global space. Ha ha ha. Okay. That means we do that. And we're going to offset and convert this. All right. That'll probably. Oh, what the? Um. Oh, ha 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 ha. Okay. Boink. Boink. Global. That should do that, I hope. Okay. That's going pretty cool too. Obviously, the sideways strife. Sideways motion, we should probably do smaller steps. We need to figure that out, how we're going to handle that. But, and of course, it just goes cross-legged there, but hey, I'm kind of getting there. All right, so now the thing that we need to do is not flip the foot forward, but we actually need to move it in that direction. Okay, so this is our target. Where do we want it to end up? And we're now going to we're going to lerp it, but we're going to lerp it with a angle. Hmm. Ta-dum, 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 ta-dum. Oh. Right. And in this case, it's going to be okay. So that's going to go from 0 to 1 every part step. So let's first do target transform dot origin is last right transform dot origin lerp target transform dot origin. Okay. That is now left transform. All right. So this should move the leg that is supposed to be in the air forward. Okay. So look. Okay, that's cool. Now we need to make it move up. So we're now also going to do, this is a problem that we're okay. I want to make this different. So in this case, we're going to do it like that. But in this case, we're only going to do the foot that is on the ground. That gets updated. All right. Do I want to? Nah, I'm going to go and put a comment in here. Transform last time ground. Transform last time right. Ground. Okay. Cool. Okay. That shouldn't make much of a difference without us doing anything else, unless we made a mistake. Okay, so that doesn't make any sense. Oh, it's the other way around. No, is it? Um, hmm. Hmm. Okay, so that is definitely not the way to go. We definitely want to know where they were. So we need to actually have a last on ground. Last on transform. I might be overthinking this. Might be, but we're getting close. So in this case, oh no. Oops. This one needs to be over here. Oh, I might as well just rename that. Because we definitely want to keep updating that every frame, but this one, oops. Okay, let's see if that works. Not really. Okay, what am I doing wrong here? Hey, it's Alex. How you going? Um, also need to reset the offset when we. It's definitely doing something wrong. So. Okay, for now. Just want to disable this bit. Obviously, when we stand still, we don't want that. Okay, why did it do that? When it jumps feet. I must have the wrong one somewhere. Hold on. This is right foot, so that's right. Left. Ah, that's why. There we go. Okay, we definitely are not going forward the right amount of time. Okay. So that suggests that this is going to be that. I'm actually going to remove all this explanation because This makes more sense to me as well, because we have pi as half a... Okay, so putting our foot down there, putting our foot down there, putting our foot down there. Okay. Okay, I'm not sure why it went so weird there, but... Oh yeah, that's because we're not resetting when we're standing still. So whenever we turn, we get screwy things, but that's fine. Okay, cool. So let's go and do the up and down thing in there. Because that's why I did all this work, is because I want to be able to do an up-down thing in. And that should be much easier now that we are doing this. I should be able to do a target origin plus equals global transform times vector 3 step offset. We're going to introduce that in a minute. Sin we're going to tau times 0.5, I think. Not 100% sure about that, but I want the absolute value of that. Oops. Sin apps 0, there we go. Yep, I know step offset is not declared. We're going to do that in a minute. We're going to do that here as well. And actually that should be walk step offsets as well. Walk step offsets. And how much do we look for? Oops. Now we're making that a nice arch, but we might need to make that something a little bit more. And this is actually possibly something that we're going to make a curve for, but we'll look at that in a minute. I might actually even do that for the whole step. Whoa. Okay. Huh. How did I manage to do that? Huh. Wasn't expecting that. What? Why did I do that? Okay, I think that maybe I went the wrong way with the sin. Let's just take that times 0.5 out and assume that I made a mistake there with how I was thinking about that. Okay, it's definitely... That is just supposed to go up and then back down. Global transform to tip it into global space. Just a certain amount up. Huh. Well, just for fun, factor times pi. Because I know that a factor goes from 0 to 1. What the heck? That makes no sense. Let's first check that. Whether I haven't done something dumb with that. A step offset is even 0, so it should be a times 0. What the? Okay, and then here. All right. I'm just going to go and take this one out. So one leg should be working properly now. Yeah. I have no idea. Global transform. So we just... What's that? Yeah. Maybe if I do it before I do my lerp. No, that doesn't make any sense because then I get only a bit of it. Hmm. Okay. Um, Now, seeing that we're not doing any sort of tilting or something, I'm only expecting to see something in here. And I'm expecting that to go just up and down. Okay. That makes no sense. Oh. Because I'm adding the freaking offset into it. You idiot. Where's the other one? I might duplicate that bit there, but... Yeah. Now, I don't know if you guys noticed, but it was doing that. So the times... okay. I'm actually going to keep that like this. It's fine. Speed. Speak it. Huh? Um, and I'm wondering if I'm not doing that wrong. No, it's not cos, it is sin. Sin should be 0 at the beginning. All right. I think I'm going the wrong way with this. Okay, hold on. I'm gonna put that bit of debug info on both sides. So I can see what it's doing. No, this is not making any sense. Oh, what am I doing wrong here? What am I doing wrong? All right, let's go and get our little graph toy. All right. We have that as a helper. Why not? Okay, so I actually want to do that. Okay. So I've got this situation now because of the way that I do factor. We now have our factor going from 0 to 1 as we do one step. You good, Bush? Meow. All right. So if we desyn that, obviously we get too little. Okay, let's put some extra brackets around that. So we need to do that times pi. That is exactly what I'm expecting. Boink, boink, boink. So this should be times pi. This one should also be times pi. So now, okay, I'm going to make that let's first deal with our UI properly so that we can actually do some fun things and make sure that we can figure out what's going on. That also means that I want to go and return this. We do want to make that work nicer, but for now that's good enough. I also want to do hold on, right here. I actually want to change this to say if velocity bigger than 0, then removing. Else we're going to reset this. So we're going to redo our walk animation. The other thing that I think that we need to do is we need to do that. No, we don't need to do that because velocity will already be positive. So that's cool. So even if you go back, oh, we'll have to figure out that actually if we go in the opposite direction, whether we need to do something more with that. All right. So first things first, this one text is, I actually want that vertical line at the top. Yeah. It's horizontal. It's a good one. No info testing, because obviously that is not expanding to the full size. Okay. So, first things first is in my layouts. I want to make sure that we have that a fixed size so that if we have multiple labels, they are nicely going to be good. And here, also want to fill. There we go. That was what I was after. So now that is nicely aligned. Okay, cool. Boink. You're going to go over here, but this is not going to be debug info. This is going to be step. Is that what we called it? I can't remember what we called it. Walk. Might actually rename that. Okay. It's going to become step height. Okay. Cool. Okay, like this. 2D. So that now becomes step height. And we're not going to have an info there, but instead we're going to have a slider. Okay. Cool. Okay, so now how do we define that? What are you doing? Don't rip cables out of my computer. That would not be a good thing. Don't think that would be good. Where were we? Step height. We actually don't have that as a range, so let's turn it into a range. Let's not go above 0.5 meter. And we'll change that in centimeters. Which means that in our ready function, we're going to want to do debug UI step height slider. We probably want to actually get a ready bar step. Oh, step height slider is that one. Actually, before I go any further with that, I do not want a space in there. Don't like spaces. Yep. Now in our ready function, we can say dot value equals walk step height. So we default to that. Now our slider needs to get our same range. So we went to 0.5 and step values of 0.1. And we also want to have... Hey, cat, stop doing that. No. 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 Whee! Gotcha. You want to say hello to everybody again? Eh? You want to say hello to everybody again? You want so much attention, huh? Hey, you good? No. Bye. Okay. Actually, let's also... Oink. Let's also give this a minimum size so that we actually have a slider that we can do something with. Alrighty, and then over here we're gonna say if the value has changed, that is going to be step height changed nicely at the end there, and that obviously means cat, you are in my way now. I cannot see what's happening. Okay, there we go. So not perfect yet, but it's getting there. Okay, so now step height is all the way over there. That makes no sense. Oh no, it does, because I couldn't see it properly. So now we can see that we are stepping really high. We are stepping really high. Dunk, 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 dunk. Cat, what are you doing? Step, 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 step. Obviously, when we're turning, we're doing weird steps, but... Don't bite on my cables, cats. You're going to electrocute yourself. That would not be a good idea. Okay. So obviously that is way too big. And obviously when we're turning, we want to do something else, but hey, it's a start. It is funny when I turn really fast, you're not happy. But I think if we turn, we probably want to do something more with that. Also, obviously, the left and right movement. We need to make sure that it figures out that it doesn't want to do as much. Probably gonna want to change some of our settings depending on how we're walking. Okay, let's get some more things that we can control so we can play around more with debugging. Okay, what's the other thing that makes sense to control? That's just how far in or out we are. That actually I don't care as much about. Or maybe I do. Sorry, I'm just having fun looking at what it's doing. I think one of the problems that I need to do is with the step height or with the foot offset. I'm going to return it to 0.15. I also need to make the magnets work better. I think the magnets aren't in a position that's good. The other thing is because now we have a nice sign when we step up, that really needs to, it needs to keep higher up until the end and then put the foot down. So we might make that a curve instead of a purely a step height. So yeah, I want to play around with this factor. So let's make that one work. So going to call that step vector. I want to copy that so that we have the same sort of so that we have the same sort of go away. I actually need to go to bed. It's 12:15. Sorry, I'm getting very tired, so I am struggling a little bit with talking while working on this, but I want to get it a little bit more. I just want to get it to a point where you can play around a little bit more with this. So this goes to 0 to 25. Let's keep the same values here. That becomes 0.1. Then here we're going to go and do that. I think it was 250 that we did with the other one as well. No, 200. Yeah, something like that. But this is where curves really go out. We might add that in there just to see how well that works. And again, one of the things that I think also needs to change is that this step factor needs to change depending on whether you're moving forward or back, how fast you're moving, just to get that to do something nice. Node. So this is on that factor changed. So in this case, we're going to have, this is on hips. I know that I've called it differently, but I just have to have that under the hip section. It's really part of the walk section as well. So I might actually move the walk options higher and then add that to walk. Anyway, so here, unready bar debug step factor. And then on the ready. Okay. Now we can see how we can control that. So we've got that. So if I make that much higher, what happens then? Oh, then I get. So the higher that is, the smaller the steps are. Although that does kind of make more sense. All right. All right. Hey, cat. All right. I just want to have, before I go to bed, I want to do one more thing, and then probably we'll do another stream on making this work even better. But just for fun, I want to step over something. So obviously, right now we're probably going to go and just get in the way of it. What do you want, cat? We do need to change our collision shapes for that. I actually might do 2 collision shapes as a result. Ground collision. Cat, you almost knock over my water. That's not a good idea. So that's a capture. That's actually not going to be very slim. And don't worry, we're going to do more with raycast to make sure that we can actually go up and down things. Okay, and then we're going to go body collision. And again, this is a little bit dumb because make unique. So That one's going to be 3, but that one's going to be... okay, and then it's transform. No, it's over here. Okay. Oh. No. So the idea here is that this allows us to collide into walls and stuff like that. And kind of be probably a little bit smaller like that. And heck, maybe that should even be more the size of the body. Could probably be a little more like this. So that's going to prevent us walking through walls. But then our smaller collision shape is going to make sure that we're still on the ground. But then if we are going to step over something, we're going to go and need to use some detectors for that. No. 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 Okay. So let's first get a something that we need to step over. Okay, that's going to have a collision shape. That's going to be a box. And that's going to have a mesh. That's also going to be a box. And I'm going to be lazy and not resize it. Oh, wait. I'm going to be lazy and not resize that. All right. I'm just going to make that something that we could, in theory, step over. That's cool. So right now, if we run this, this will stop us from moving through that. Dink. Right. That's a shame. It's going to be right where we want to step, but I'm going to cheat and I'm going to move it a little bit closer. I don't want to deal with that just yet. Whoops. Don't do that. I'm Windows. Okay. So now full step, because I, of course, got into trouble with that. You know what? Let's move that up a bit. Okay. Oh, so I managed to step into it a little bit. Anyway, so see if we can get a raycast to work to make sure that we can't get through something. All right. So for this, we now need to do a raycast. Yay! All right. So that's a good one. This is not. Oh, hold on. We can cheat, I think. Can we? No, we don't have a physics buddy in here. Or this physics server 3D. All right. So we should be able to get a state from this, with which we can do things. But that is for space. Okay, so how do we get the right space? Because I think we always need... Okay, so we're going to have to get that from our parents. All right. Yeah. Parents is, yeah, parents. parent is character body 3D. Do this. Actually, I think I can do that for any physics body. Or is it even for any collision objects? Well, I can get the RID for that. Hmm. Physics server, hold on. Get space directs physics space states. And then for body, I can do a body get space. Just body. Okay. And I think any collision object has that. So I can even check on collision objects. Okay. Is a cool. All right. So our space is physics server 3D dot get no body get space parent dot get rid, and this is going to be space get direct state for space. All right. Because with that I can do an intersect ray. Cool. And that was a rid, I think. Yes. Okay. So now we need a ray query. Query. Come on. My control button is sticky. All right. So we need to first set up our query. Yay. All right. So we can probably use a collision. So I don't care about this. Area should be false, body should be true, but collision mask. Query.collision mask. I probably want to do parent.collision mask so that we use the same mask as our character, which is cool. We probably also want to exclude. Oh, where are you? That's an rids, so we actually want to do bar body rid get rid, and I'm going to do query.exclude because we do not want to have the ray ever hit our body. It shouldn't, but you never know. Want to make sure we exclude that. Is body rid. Yep. What else do we need to do? We don't care about that. We don't care. So now just from and to. So now our query.from is going to be target transform origin plus target transform dot basis.y. So we're gonna do it from a little bit up. We probably want to have a factor for that. Let's go and make that here. Export var walk array offsets floats. Let's make that 0.5. Offset for our placement array casts. Okay. Too far. Where am I? My logic. Here we go. Times that. Y2. I want to go in the other direction. So when I've got my foot on the ground, or hopefully what's on the ground, we're going to do a raycast from slightly above through the ground up there to the bottom, so that we know whether we're going to hit something. Okay. And of course, if we don't, then we're in trouble. But that's okay. All right. So now we're going to do vision is state dot intersect array query, and then here we're getting something that is not empty. Okay, query, and then here we say if collision is empty. Obviously, if not collision is empty, then we're colliding with something. Then we're going to say target transform dot origin equals so we're going to go and do our intersection. So we can also use our normal there to place our foot correctly, but we're not going to worry about that just yet. So I'm just going to do it to do here. To do use normal to orient. Oops. All right, let's see if this does something. Okay, so problem that I do have here again. Yeah, whatever, don't care. Just gonna disable this again. Means that we get a stupid starting position, but oh, because it's dang it. Because we set our hips offset if we're not moving. Okay. So yeah, because we're stopped there, we got okay. So we need to do the up-down thing as well. So for that, we're actually going to add some raycast objects here. Actually, let's put a helper node here first. Please. For okay. Okay. That's good enough. We want that to be split up. Let's say that's the highest that we want to be able to go with that. And then our raycast. Yeah, we don't really care because we're only going to go up with that. Okay, so we want to have one that side. Have one on that side. I'm going to have one on that side. So basically what we're doing here is detecting if we're hitting something before we actually get to our, what you call it? To our collision shape. And if so, we're going to lift our body up. Okay. So that's now going to go in here. So here we're doing is on the floor. Start with that. The reason I'm doing this is because I want to do it both on our reclining with our main collider, but also we're going to go through our raycast. So, child in floor detect dot get children. We know that these are all raycasts. So, do we care? Well, let's just do that. If we do something dumb and put a child node there that's not a raycast, we can get an error. That's fine. If raycast is colliding, okay, and then actually we're going to make sure that that is always minus 0.4. We're going to do that on all of them. So okay. All right. Get collision points. Okay. So we get our collision point, but we want to transform that into local space. So for that, we need we don't need the actual transform of the raycast. We want that in the global transform space of the actual character body. So now we can do that times that. That's not the 3D, that's just vector 3. So we get a collision point, and that now means that we can, okay, so that's going to be a collision point. Where are we colliding? We're putting it in local space. We are putting it in, local space of the body. Body is on the floor or is on the ground 0, so it's only when that is bigger. So this is going to be is max offset, comma, where dot y. Cool. And obviously on floor is true. If offsets, actually we don't care, we're always going to do that We are going to say transform dot origin dot y. Let's see its offset. We're just going to add the offset to it. Okay, let's see if that wants to work. We are walking over. Yeah, because it's hitting it. Okay, let's see if we can make a stairs out of that. Test 3D. I actually want that in one direction to be less. So, this direction? Yep. Same thing for this one. Okay. Whatever. I think I want to make it bigger. I think that is too small. Let's make it 0.5. And here also 0.5. Okay. Oops. This guy. So that's 3. That's 1. That's 2. That should be there. Let's also do something similar for this. 2.5. That is going to become 3. And that becomes 3.5. That becomes 4. That becomes 0.3. Okay. We got ourselves the stairs. Now with that, I also want to go and increase this a little bit. So we do smaller steps. Okay. We need to make him walk slower, I think. Because right now it feels like he's going inside of that. Walk. Character buddy. Let's make him walk real slow. Let's put that up to 12. Okay, I think the problem here is, besides it's fallen down, it's actually kind of interesting because the raycast should be moving him up. So now he's up. Okay, I want to see my collision shapes. Let's see if that tells us a little bit more about what we're doing here. Okay, so now we can see our raycasts. Ah, we have our collision shapes misaligned. I messed up our collision shapes again, didn't I? Which ones are wrong? This one is wrong. Boom. Okay. Let's play. Okay. Now we're going right. Yeah, that's much better. Now the raycasts from the feet obviously are on the middle of the feet. So we can see indeed that our shoes can go inside of So we might need to do the raycast a little bit forward. But still, you know, he's walking stairs. He's walking up the stairs. You know, it's not a very natural walk just yet, but pretty happy about that. Whee. Yeah, the step turning is a little weird. And I think we're well, you know, obviously nobody does this in real life, but I think, you know, I think when there's turning, we should do more. And of course, it's side by side. Oh, this is actually kind of be fun. Okay, other way. Yeah, that's kind of cool. So this way we can't, because the raycast is actually, that's kind of interesting because yeah, won't let us do this. That one is just high enough for it to reach. That's okay. Yeah, that's damn cool. Can I run up the stairs? So this is indeed where I think our step factor needs to change depending on how fast we're moving. I don't think that is actually... Speed walking. This is actually kind of hilarious. I like this. This is fun. Yay! Okay. Oh, sorry, guys. You saw the screen was cut off a little bit there. Get RT support for, what do you mean? Ray tracing support? Ooh, I don't know. I'm not really involved with that. I know that there are people interested in working on that, but that's a big job. So who knows? All right. Guys, it's nearly 1 a.m. I actually have a meeting in about 6 hours, so I'm not going to get enough sleep tonight. I think we're gonna end it there. This is a fairly decent start to doing this. You know, we have our foot placement working fairly well. I think we need more logic around if the person turns. So there needs to be some overrule there. Obviously, right now, when I stop moving, I stop immediately. I actually need to make sure that we finish the step that we're doing. So basically, whatever foot is up in the air goes down to the ground, and as soon as that goes down to the ground, we catch up with the other foot until both feet are underneath the player. But also, turning needs to be done even when standing still. So I think when there's a turn, we're going to do some extra movement with the foot that's off the air. So so there's going to need to be something that is... I think what it boils down to is probably that we're going to flip what we're doing around. So right now, I'm doing the bobbing and the hip movement and then placing the feet. I think I'm going to turn that the other way around, where I'm going to place the feet depending on the speed of movement and the speed of rotation. And just basically say like, hey, one foot is on the ground, the other foot has a target based on the velocity, on which way we're going. And we're going to keep moving that foot until it is where we want it to be. And then depending on where we are in that movement, we're going to make the body go up and down and move the hips. So I'm probably going to change the way that works away from the way that I've currently got it working. Other than that, I think the body leaning, we can keep the way that it is. That makes sense. So yeah, I think that we have a good base here. But there's definitely a lot more work that needs to be done in this. I don't know how soon I can follow up on this. I have I'm not sure how I'm tomorrow night. Maybe I'll do another stream tomorrow night if I'm not too tired. Friday night, unfortunately, I've got meetings, and I've got appointments all over the weekend, so I don't. Maybe Saturday. Yeah, either tomorrow night or Saturday night, we'll probably do another stream to continue on this. And then, like I said, I'm probably going to flip around the way that we are doing. Might even disable the hip movement for a little bit and purely work on doing the foot based on which foot is on the ground and our velocity, including potentially looking at, okay, how do we deal with angular velocity to move the foot? So, because I think that's where it really boils down to, right? Is you have one foot on the ground that stays on the ground, and the other foot is moving towards where you want to be. And we need to do a prediction where that needs to be on the ground, and then depending on some frequency, make that movement happen, make it go up and then back down from its last on the ground position to its new position. Yeah, I think basically the distance there, we're gonna make a curve that moves over there and then make sure that the foot moves. Still want to do something about getting the feet to be more closer together. Yeah, I think that I think we're gonna change that logic. We're gonna probably move that around, and then again, the hip movement we'll do based on basically the calculation of where are we with the foot that's in the air. Okay. I'm happy. That's pretty damn cool. So I see that there's a bit of a delay in the stream. I'm still walking around like crazy in the stream. I wonder what that's going to mean. Yeah, I think I'm about a minute ahead of you guys. Interesting. So yeah, thanks everybody. My cat's back. Hello, cats. You want to say goodbye to everybody, cats? Cool. I'm going to leave it there. Good night, everyone, and see you next time.